So I had planned to have this video be some sort of live interactive stream, but that didn't work out. So it's just going to be me going through some of the applications in the latest DragonOS release, the public R3 build. I know I had talked a little bit about srsLTE. I've had some questions on the Imsi catcher script. I want to show a couple things you can do to fix that up. Tetra-kit, I've had questions on that. That's not included, but we'll show you how to add that real quick. And then if I can get around to it, the Iridium-toolkit. But I have, and I'll put all these pages in the description here, but you can see this ZeroMQ application note. That's what I want to go over for with srsLTE. And it basically tells you here you can set up an end-to-end solution with an eNodeB, a UE implementation, and then the core network. And then you can use this for a number of use cases, it says, where you don't have an RF front end or it might not be needed or wanted. You can skip all the way down to running a full end-to-end LTE network on a single computer. And we'll start right here. You're going to have multiple windows open to do this, but we'll follow along here. That's going to add the new network namespace of UE1. Let's make sure that it is listed, and it is. Now we'll start the EPC. It says here this will create a tune device in the default network namespace. You got to use sudo with this, and of course we have everything installed, so we don't need to run it from the source directory. You could just run it like this. We'll run that in one window. Now we're going to launch the eNodeB, and this first instance we don't need to run with sudo, but I do want to try and get the whole thing in here. Back here. Let's remove that. You'll notice that the TX port is on 2000 here, and then the RX port's on 2001. So that's started. You can see it sent a response there. Now we got to launch the UE again, this time with root permissions in order to create the tune device. Got another terminal here. You'll notice this time the TX port is on 2001, RX port's on 2000. Pay attention to that if you're like typing this out, not copying and pasting it. I had it, didn't realize that, and had it both the same each instance. So we're going to start this up. We'll wait for the PHY to initialize. And while that's doing that, once this is all running, then we should be able to ping that IP of 172.16.0.2. So you see where the network attached is successful. We had some interaction here and in this window. Let's open one more window. Now keep in mind this is all installed. I'm literally running this live, so I was trying to get this right so we can bring up a LTE network with the right equipment. So now we can ping. Okay. And one last thing here, in order to generate traffic in the uplink direction. We'll try this out. Okay. So everything is working, at least as far as I can tell, according to the directions on srslte.com. And then it's important for a clean teardown. The UE needs to be terminated first, then the E and B. So if we remember, this was the, I believe the EMB. Come over here, kill this, and then kill that. Delete the interface. Okay. All right, so that's a walkthrough. You should be able to follow along. I'll put the page there so in case I went too fast in the terminal windows here. But so that's that. Let's take a look at, let me see, let's take a look at the tetra-kit. So I think some people had problems getting this tetra-kit up and running because they were using the incorrect version of right here, this no, sorry, the JSON here. I see the developer put a link and now specified the version that you need. But I noticed, I think this is sufficient. Let's see, let's close these out. I noticed with 18.04, you can, here we go. You can install the libjson c dev like this, which I already have done, and it gives me the 12.1.1. I think that's going to be close enough. And I had someone check this, seemed to be working fine. Let's pull this down. And this is not included in DragonOS, so I know I normally stick it in the the user source directory, but for the purposes of this and running it live, let's just put it in our home directory. Show you how easy this is to build. Just follow along right here. So we're in the tetra-kit. We change to the decoder directory. We run make. That'll build what we need there. Come up a directory and change into the recorder. We'll build that. Come up a directory, change into codec. Let's build that. Then let's copy the C decoder. Just as it says. And we'll do the same for the S decoder. Okay. If we come up and we go to the PHY and we run the GNU radio companion, this is where I noticed an issue. You'll see the two GT or Qt GUI entries here, red. You open them up. I'm sure it's just a simple search and I'll figure out what's wrong here. I don't know if this impacts much of anything. If it does, let me know, but I blanked that out under the hint. That goes away, and let's see, let's follow along. So for usage, if we open 3 shells and 3 folders, back to our tetra-kit decoder, run the decoder in one window. Let's go to the recorder. Got that. And we already did the PHY part for the, with the GNU radio. So we'll come here. I've got an rtlsdr plugged in. You can change the frequency. Let's see. Oh, it would help if I had the rtlsdr plugged in. Let's try this again. Okay. And I have 0 tetra around me, so I won't know if this works. I'm curious, I had someone say by changing this and hitting enter, oh yeah, sure enough. I'm not sure why the crashing of the flow graph there, but we might be able to change default. You might be able to change the frequency there. Let's see, it's being called frequency. It's got an offset, so it's calling frequency megahertz right here, and then the offset. Well, maybe someone that actually is around Tetra, you can try and see how this works for you. Okay. All right, next up, let's take a look at the Imsi catcher script. Everything's pretty much in there that you need to get this up and running. The one thing though, and you notice it says here Python 3 Scapy, install, just do Python Scapy. I've already installed it right prior to this video, but if you have the latest release, you still need to install that. And I have found that that'll come in handy. It says with old versions of GRGSM, and then there's a new version, but I found that if you do, after you install that package I just said, if you do sudo python, well actually change into the user source Imsi catcher, and if you do sudo python simple Imsi catcher -- sniff, that will come up, and then you can, in a separate terminal window, you can do GRGSM scanner. Now the benefit of this is, and have a look at the help file here, you can specify arguments for the device that you're using, and that comes in handy because if you're using the hack RF and you don't specify the device arguments, kind of behind the scenes it gets mixed up with UHD, and just you need to be able to specify. I have an rtlsdr plugged in, so you really don't need to do much of anything, but the example would be like this. If I wanted to say specifically call a hack RF, say we only had one plugged in, it'd probably be hack RF.0, but for the rtlsdr, got like this. Now I'm not going to see anything because I have 0 again GSM around here, but by doing that you can like listen to frequencies, base stations that are around the area, and then you can go and do the example here of specifying a specific frequency you want to listen to. The other option is the that you can do as well is just like it says here. You can go into the user source Imsi catcher, you can actually do Python 3 on this one, and that will run there, and then you can do the Python scan on LiveMon. To fix something so that's more stable, I found that if you go to the Imsi catcher site, look at one of the pull requests, and updating the simple Imsi catcher, this I found makes it far more stable. If you say open up with your favorite editor, the actual script, and let's see, I believe it's line, yeah, around about line 51. So if you did control underscore, you'll see you can enter the line number 151. This is nano anyways. Come down, you come over, and you'll see I've already implemented the changes, which is right here in green. You can see the Imsi country, Imsi brand, and the Imsi operator, which if you look, really that's all that's being changed here, right here. Add that, make it just like that. It works out great. Okay. And let's see, one other thing. What else we got? So for the Iridium-toolkit, is included in DragonOS. It's under the Iridium-toolkit. The only thing you might want to add that I didn't is this pypy. You can do sudo apt install pypy, which I did just a second ago. That way when you try to run the examples, that will work. I did not include the codec that it talks about here. So if you just remember where you're putting it, I'm just putting it in user source here. If you clone that, pull that down, change into the Osmo, look around, you'll see there's a codec folder, change in there, depending on where you have it. Here I need to use sudo. If you put it in your home directory, you won't. You'll run that. That'll make the, in green there, you can see the A and B decode. Just copy that to the user source Iridium-toolkit folder. All right. Now you're pretty much set up where you can follow the rest of the directions, but when you start this stats voc thing here, the important thing is, and let me see, you want to, and it says it here, let's see, you want to export right here. You want to export your path. So just remember this. This will close this in. Whatever terminal window that you're going to want to run. And now you could edit the stats voc and make it to where you don't have to do this. But if you do, if you export path and do user source Iridium-toolkit. Now when you run your commands in within the toolkit, they'll work. And if you have a close look, and you'll see why, if you have a close look at you can see, if you look through this file, you'll see where it calls for the play Iridium A and B. Now you could fill out the whole path to that and then you wouldn't have to do the export thing. But that's what I found works. Now, keep in mind, if you close the terminal window and if you don't set that to be more permanent, when you open the terminal window, you have to do it again. Okay, that's pretty much it. I think that's quite a few things covered there. There is one other thing, actually, now that I think about it. But if you look up modmobmap, I've made videos on this before, you'll notice that here recently the repository moved, and what I found it interesting is previously this was requiring a phone, a specific phone to work with it, but now you'll notice it can work with GRGSM scanner and can use all the devices that are listed here. And I noticed if you scroll down, so this is something I'm going to go back to and add in the future. If you come all the way down, this new section's been added, modmobmap with GRGSM. And you can retrieve the GSM cell information now, which, like I said before, was with a phone and the Android SDK. Now with just your what you're used to, the software-defined radio device. So I'm going to take a look at that and try that again. So, okay, that's all. Thanks.